Hello, everybody. Miss Sola here with Unit 1, Lesson 1 of Intermediate Algebra. So let's go ahead and open up our notebooks. And for today, we're kind of going to do a little review. 1.1, Order of Operations. This is sometimes called PEMDAS. I'd like to start all of my algebra classes with a little review on this, just so we get back into the feel of how numbers work and where, what to do first, what to do second, all of those things. So I'm going to add this to my table of contents, and then I'm going to open up to the very first blank page and write the same thing. 1.1, order of operations. Sometimes, like I said, this is referred to as PEMDAS. This is going to be a great page to check back on throughout the year if you need a little refresher on anything numbers, algebra related. So PEMDAS, this is an acronym. There are kind of four pieces to it. The first is the P. P stands for parentheses. Parentheses look like that. But what I kind of want to talk about with intermediate algebra today is the times when these parentheses are invisible. They're going to be sometimes invisible. And when they're invisible, I like to call them groups instead of parentheses because they're not physically parentheses. They're just groups of numbers that we're going to take a look at first. Okay, so here's a couple examples of that. So for example, if I had 12 raised to the 8 minus 6, notice how 8 and 6 are in the exponent together, and the 12 is kind of on its own separately. That is a group. There is an invisible set of parentheses around the 8 and the 6. So I'm going to simplify that first. I wouldn't take 12 to the 8th first. I'm going to simplify that first. So that's going to go 12 to the 2. And 12 squared, or 12 to the 2, is 144. Here's another example. So let's say I have 5 times the square root of 12 plus 4 minus 6. I don't see any parentheses there, but I do see one group of numbers that are together that kind of have nothing to do with each other. The 12 and the 4. The 12 and the 4 are together in this parenthesis, or in this group. Even though there are no physical parentheses, there kind of is a grouping there. So I'm going to simplify them first. 5 times the square root of 12 plus 4 is 16 minus 6. And then the square root of 16, or what times itself is 16, is 4. And now I'm just going to kind of go right to left here. We'll talk more about these later. 5 times 4 is 20. Minus 6 is 14. I add some equal to signs. Woo! And one more little example of an invisible set of parentheses is with a fraction. So let's say I have this fraction, and on top in the numerator, 25 divided by 5, and on the bottom in the denominator, 16 minus 15. I don't see any parentheses here either, but there are really two groups. There's the group on the top in the numerator, and there's the group on the bottom in the denominator. So there's really two sets of parentheses here that we need to simplify first. So on top, 25 divided by 5, that's 5. On the bottom, 16 minus 15, that's 1. And now Fractions, great. This is written as a fraction. It's also the same thing as a division. So 5 divided by 1 is 5. Okay, so that's the P. That's parentheses. Anytime there's a group of numbers where you got to simplify it first, there's something special going on to just that one. Then I've got E. E is exponents. Or sometimes called radicals. Or a radical is just kind of a fancy exponent, essentially. So things like the square root is a radical, or a cube root, or something raised to the third. So this exponent, these are things we're going to take care of first, an exponent or a radical. Okay, I've got 2 examples for this one. Let's go pink. Kind of hard to see. Never mind. Okay, I've got 2 examples for this one. For example, if I have 3 squared times the square root of 81 minus 10. So the things I'm going to do first here are the exponent and the radical. This is an exponent. This is a radical. So 3 squared, that's 9. The square root of 81, that's 9 times, or sorry, what times itself is 81. 9 times 9 is 81. So the square root of 81 is 9 minus 10. Now I'm going to go again kind of right to left. 9 times 9, 81, minus 10 is 71. But I had to do those exponents first. Here's another example of that. This one looks a little messier. Let's say I've got 2 to the 2 to the 2 to the 2 divided by 2. So when I've got sets and sets of parentheses like this, I want to start inside most as I can and work my way out. So I'm going to start on the inside most parenthesis here. So let's see, we'll go 2 squared is 4. Now I'm going to leave everything else the same. To the 2 to the 2 divided by 2. Now my inside most is 4. So I'm going to go 4 squared, that's 16, divided by 2. Whoa, 16 squared. I don't know that off the top of my head. But if I type it into a calculator, it is 256 divided by 2, 128. So you start on your inside most, work your way out. Doing the exponents first, then divide everything by 2. Now there's 2 more groups here in my PEMDAS situation, 2 more groups. M and D are kind of together. So I've got multiply is what M stands for, and divide. And remember, like, all the different ways I can write a multiplication sign. There's a lot of different ways. So, can we see that? No. So I've got, sometimes I can say multiply by, I can say times, I can put a dot, I can put a star, I could have just like nothing in between. Like 5 squared of 16. That was a multiplication symbol. There's nothing there, but it was multiply. And that's going to look like 3 times 4, or 3 dot 4, or 3 star 4. things like that, things like that. Now, division, it can be written in a couple different ways too. I like to say it can be a fraction, like number divided by number. It can also be sideways, like a number divided by a number like that. It could also be like an actual divide symbol, which the division symbol is just kind of shorthand for fraction. Okay. And some examples we had of that up here is first we multiplied, then we subtracted by 10. First we multiplied, then we subtracted by 6. Here was a little division problem. And the very, very last AS of PEMDAS stands for addition and subtraction. Oh, and these ones, they're going to go left to right. So addition and subtraction, it's also going to go left to right. Like once you've simplified all the other things above it, and let's say I just have a huge line of addition and subtraction things, which one do I do first? Start just like you're reading. Start at the left and go to your right. I'm going to get a little fancy for this final example and add some letters into it because this is algebra. So let's say I have A is equal to 2, B is equal to -3, and C is equal to 7. So I'm gonna write an example here, and we're gonna solve it by plugging in the numbers. So for example, I've got BC plus 5 all divided by -A. I'm going to plug in all of these numbers. So B is -3. When I'm plugging things in, I like to just throw parentheses everywhere. B is -3. C is 7 plus 5. There's no letter there. All over -A, -2. Okay, so looking at this, what to simplify first? It looks like I've got two groups, the top and the bottom. So I'm going to simplify the top first. Run out of room. So -3 times 7 is -21. All over, that's just going to be a -2 on the bottom. I've still got a group on top and group on bottom. So I'm going to keep simplifying the top there. A little more space. Equals. So then on top, I've got -16 divided by -2. And a negative divided by a negative, just like a negative times a negative becomes a positive, is 8. Another example of this could be just a really short one, just to throw an exponent in here. If I had like B raised to the A, B is a negative number, so we have to be careful about that. It's going to be in the parentheses, -3 raised to the 2. And anytime I'm squaring something or raising it to the 2, that really means like do that parenthesis twice or multiply that thing times itself. -3 times -3 is +9.